And welcome back. In this video or tutorial, I'm going to show you part 2 of our discussion of the chi-square goodness of fit test. In this case, we're going to look at how to apply a chi-square analysis for two factors or two variables. And if you remember from our previous video, in this instance, we are looking for independence or testing to see if the two variables are independent of one another or if they are some way associated with each other. All right. So let me show you the example data that we're going to look at. Now, in this instance, we are looking to see, the research question is whether there is a relationship between personality type and pet ownership, okay? And so in a chi-square context, we're looking to see if personality and pet ownership are independent of one another or if there's some relationship there. And what I've put on the slide here are the observed frequencies for our research. So, for example, in this instance, we had, here I'll use red, 55 introverts owned cats compared to 22 introverts who owned dogs, compared to 12 introverts who owned birds. All total, we had 89 introverts. And then as far as people who were measured as an extroverted personality style, 20 of those owned cats, 73 owned dogs, and 18 owned birds, for a total of 111 extroverts. And if we add those together, you see that all total, our N is 200. Okay? And then along the bottom in our columns, there were 75 cat owners, 95 dog owners, and 30 bird owners. Right? So we had 89 introverts, 111 extroverts, 75 cat owners, 95 dog owners, 30 bird owners, and we're looking to see if there's a relationship between pet ownership and personality type. The null hypothesis being that there is no association between pet type and personality, that is, they're independent of one another. And the research hypothesis is that there is a relationship or an association between pet type and personality, that they're not independent of one another. So you may remember from the previous video, the formula for chi-square is observed minus expected squared divided by expected. So things are going to get a little bit trickier here as we calculate the expected frequencies. So let me bring up a fresh screen and let me show you how to calculate expected frequencies, okay? All right, I'm all set up now to show you the expected frequency calculation for the chi-square two-variable test. And the formula for calculating, this is just for E, okay, just for calculating our expected frequency. It is we're going to take the row times column divided by total, okay? That's all you have to do. So if you notice for the expected frequency for introvert cats, we're going to take the row total for introverts, which is 89, and the column total for cats, 75. We just multiply those two things together and divide by our total of 200. And how do we arrive at that? Well, let me show you real quick. What is the probability of being an introvert? Well, the probability, if you remember, is there are 89 introverts divided by 200. That's the probability of being an introvert in this study. And what is the probability of being a cat owner? Well, there are 75 cat owners out of the 200. And so the question is, what is the probability of being both an introvert and a cat owner? What do we do with probabilities when we have an and statement? We simply multiply them. That should be 200. We simply multiply them together. 89 over 200 times 75 over 200 is the same thing as saying 89 times 75 over 200. So that's all we're doing, is we're just calculating a straightforward and probability using that multiplicative rule. Now we have to do that with every single column, or excuse me, every single cell in this particular study. I'm going to clean things up a little bit. And that's exactly what this particular table has done for you. We see here's that 89 times 75 divided by 200. Now, to find out the probability of being an introverted dog owner, we once again take 89 times our column total of 95 and divide that by our total. For being an introverted bird owner, we take 89, that's the number of introverts, times 30, the number of bird owners, divided by the 200. And so on, and so on, and so on. We're going to do that for all 6 cells. We take the row total times the column total divided by the total n in the study. And through the magic of technology, I've just changed that the contingency table, is what we call this, to reflect the observed and the expected frequencies. So if we look here, we had 55 observed cat owner introverts, 22 observed dog owner introverts, 20 cat owner extroverts, and so on. So those are all of our observed frequencies. And then when we did the row times cell divided by total, I should make that just say total, we get 33.375 introverts, 42.275 expected introverted dog owners, 13.35 introverted bird owners, 41.625 extroverted cat owners, and so on and so on. So in this table, I have both the observed and the expected frequencies. And that's step 1, is to calculate those expected frequencies for each cell using the row times column divided by total formula. And once you've done that, you are now ready to calculate the chi-square using the appropriate formula here. Okay, so if we were to put this into the formula, we would simply take the observed minus expected squared divided by expected for all 6 cells. That would be something like 55 minus 33.375 squared divided by 33.375 plus, and then we do the next cell, 22 minus 42.275 squared divided by 42.275 plus dot dot dot. We would do that for our 1, 2, 3, 4, 5, 6 cells all the way down to the 18 minus 16.65 squared divided by 16.65. Okay, now I just put the little ellipses in there to show that we've, moved ahead, but you have to do that for all 6 cells in this example because this is a 3 by 2 contingency table. 3 levels of the pet variable and 2 levels of the personality variable. So 3 times 2 gives us 6 cells. And when you do that for all of them, you end up with a total chi-square of, let's see if I can fit it in here, 43.013. 43.013. So why don't you take a minute and do that for all 6 of those and see if you come up with the same answer that I do. All right, I cleaned things up a little bit. Remember now we have a chi-square of 43.013. Hopefully you got that as well. And now, once again, we have to simply compare our calculated chi-square to a critical value. And once again, this is also based on degrees of freedom. In a 2-variable chi-square test, the degrees of freedom is calculated by the number of columns minus 1 times the number of rows minus 1. Well, how many columns did we add? We had 1, 2, 3 columns, so 3 minus 1, times how many rows did we have? Well, we had 1, 2 rows, introvert and extrovert, so we're going to multiply that by 2 minus 1, which gives us a total of 2 times 1, or 2. So we had 2 degrees of freedom. If you look up in the tables, the exact same critical value was our one-way chi-square that we did in the previous video. So we know that our critical chi-square is 5.991. So my question to you is this two-way chi-square significant? Well, we calculated our chi-square as 43.013, comparing that to a critical chi-square of 5.991, and yes, that is significant because our calculated chi-square is larger than our critical value. That is, it is greater than what we would expect 5% of the time, with an alpha of 0.05. So the conclusion is that there is an association between pet type and personality. The question is, what is that association? And here's where chi-square gets a little artistic, because what you have to do then is look at the data and sort of describe it. So let me clean things up. Well, we'll just use this screen here. So we see here for introverts, overwhelmingly, there are more cat owners than dog or bird owners. Whereas for extroverts, if we look things over, we see that there are more dog owners than cat or birds. And so that's the way that we would describe this, is that there is a relationship that introverts tend to own cats more than dogs or birds, whereas extroverts tend to own dogs more than cats or birds. And neither group really had a dramatic preference for birds over the other type. So it's just a matter of describing the pattern that you see. In the case of chi-square, there is no post hoc test where we could go in and make individual comparisons. We just describe the pattern, and that's all I've done for you here. One other thing that I wanted to once again make note of, and that is getting back to those expected frequencies. Let me kind of clean things up here. If you remember the two rules for expected frequencies, the first is that no cell can have 0 expected frequencies, and clearly that's not the case. We had 33, 42, 13, 41, 52, and 16. And that no more than 20% of the cells can have an expected frequency of less than 5. Well, once again, we're well beyond 5 for all of these. However, if you were to come across a set of expected values that did not meet those criteria, that one of them had a 0 or more than 20% of the cells had less than 5, you should not calculate a chi-square test. So, a little word to the wise for upcoming exams, to be aware of those two rules for calculating a valid chi-square test. But other than that, that's all there is to it. So in the last two videos, I've shown you how to apply a chi-square analysis to nominal data. The first video, we used just one variable and looked to see if the pattern of observed frequencies differed from what we would expect by chance. And in this current one, we compared or looked at two variables, looked to see if those variables were independent of one another or if there was an association or relationship between the two. And in this last example, there was a relationship, that there is a relationship between personality style and pet ownership. And that's all there is to chi-square. Very, very simple, formula and fairly easy to apply. Just remember, once you calculate your expected frequencies, that's just setting the stage for conducting the actual chi-square analysis. In the past, I've seen some students just complete the complete the expected frequency calculations, and then they're done. And that's not the case. Once you have the observed and the expected, then you can plug everything into the appropriate formula. So that's about it. I hope that clarifies how to apply the formula. You'll read more in the textbook chapter about the meaning behind it, and you'll get some more examples there. All right, thanks for listening.